So I spent a couple of hours on this device, which is an e-ink device, and it tells you the time, which is not very apparent because the time is actually in words, and those words are a quote from a book. So it's a literary clock. Let me show it to you in action. So the device needs constant power to change the time. Without power, it just displays whatever was the last display. Any 5-volt power source will be fine. And as you can see, it is 2:28 on my watch, and so it is in the literary clock as well. Coincidentally, it also showed the correct day, but that won't happen all the time. That was just one coincidence because the clock only shows the time codes. So the time has changed, and so the device also changed the text, and now it shows 29 minutes past 2 in text form. The flicker you saw, that's the e-ink device characteristics. Uh, it will always flicker when the display on the screen changes. Even the terminal device in the back does that when the screen changes. So we have time. So let's wait for 1 minute to get over so that we have new time and new code. The screen will flicker once more. Just wait for that few seconds. Okay, so the time changes and now we are 2:30. See, the time is 2:30 in my watch, and the quote is, she looked at her watch 2:30, a few minutes to calm down before she had to go. It's a quote from the book The Locked Room by Maz Sowal and Parvalu. I hope I'm pronouncing their name correctly. So let me show you how I did that very quickly. The code is on our GitHub repo, and this is the device I used in the demo here. It is a CrowPanel ESP32 based 4.2 inches e-paper display. Earlier I used the term e-ink, which was not correct. E-ink is a brand of e-paper display. So now this device can be used for various purposes like meeting room display, calendar, and whatnot. But I used it as a clock, a different kind of clock. Elecrow has some demo code for this display device. I took that and I took inspiration from another project called LitClock. An awesome project that is, and where you can configure your clock via Wi-Fi over a browser, I think. And it can build on Raspberry Pi Zero 2W and WaveShare devices that I didn't have. So I took the literary codes data from this project. I think it's in the data or doc somewhere. So I took that data and I mixed it with the sample code provided by Elecrow, mixed them. And so this is the codes.csv file, and you can see the time in codes here. So if you want to build a literary clock on your own, this is the data you need. You can use an LLM to modify the code for you, and it's quite simple actually. This is what I did actually. So I had the code mixed, and then what I did was ESP32 is coded through Arduino IDE. So I connected the e-paper display to my system, chose ESP32 board, in the tools, set the port, chose OPI PSRAM, and since the CSV is more than 1 MB, the partition scheme is set to be huge. And that's more or less, I think. The code needs Wi-Fi credential hard-coded. So I have that in the code here. You probably don't see it, thankfully. Just hit the upload button and then we wait for some seconds. The output will tell you whether you are on the right track or not. So here it says, okay, auto resetting the RTS pin. That is a good thing. Wi-Fi is connected in the serial monitor. Good. So this is all it takes. You can check out the GitHub repo in the description below and try to build something of your own. So if you have an e-ink device or actually any other display device, you can literally make a literary clock for yourself. All you need is the data, the codes data, and then you can plug it in to your device with whatever OS it uses, and then you will have the literary clock for yourself, and it's pretty cool to have it on your desk. I hope you like this idea, and I hope you like this video and enjoy building something for your home or home lab, and I'll see you in the next video. Bye bye.